The night sky looks still, but it is anything but silent. Behind every star lies a secret. Behind every patch of darkness a hidden structure, and behind every breath of empty space a restless depth that shapes everything. What follows are surprising truths about the universe, facts so unusual and delicate that they rarely appear in ordinary thought. Each one opens a door into mysteries both vast and intimate, carrying the mind outward until sleep itself feels like a journey across the cosmos. By the way, if you like and subscribe to my video, this is the most effective way to support me. If you can tell me where in the world you are watching from and what time it is, I would love to read it in the comments. 1. Quantum foam at the foundation of space. At the smallest scales imaginable, space is thought to be restless and uneven, more like a sea in constant motion than a smooth void. This concept is called quantum foam, and it suggests that what appears silent and empty is instead filled with fluctuations so brief and tiny that no instrument has yet touched them directly. Particles flicker in and out of existence, virtual shapes form and vanish, and the very idea of emptiness becomes misleading. The night sky that looks still and serene is layered over this foundation of restless activity, as though silence itself were woven from countless whispers. This foam is not something that disrupts daily experience, because its effects are faint and hidden beneath ordinary scales. Yet its existence could explain why matter clumps together the way it does, why gravity behaves as if guided by rules deeper than geometry, and why the earliest light carries patterns that look like fingerprints left by unseen hands. The very first moments of the universe may have depended on these microscopic dances, setting the stage for galaxies, stars, and decorated planets to emerge billions of years later. The idea is striking because it changes the meaning of nothingness. A region with no stars, no gas, and no dust is not truly empty but still active, at a level so fine that only mathematics and indirect evidence reveal it. To imagine this is to think of a canvas painted so smoothly that the brush strokes are invisible, yet on closer inspection every fibre of the cloth is alive with texture. The background of reality becomes a quilt of motion that never rests, even when everything else is still. If one day new instruments trace these minute fluctuations, they may show that the calm face of space hides a secret foundation, busy and fertile. Whether discovered or not, the suggestion is enough to shape thought. It is not emptiness that holds up the universe, but a dynamic depth that hums quietly and steadily, carrying the weight of everything that exists. 2. Dark matter holding galaxies together. When astronomers measured how stars move around galaxies, they found something unusual. The stars on the edges travel too quickly to be bound by the visible matter alone, as if gravity were being provided by an invisible framework. This unseen mass is called dark matter, and though it cannot be touched or seen directly, it shows itself through its steady pull. Galaxies spin without falling apart because of halos of this hidden substance surrounding them, silent and massive like scaffolding in the dark. The presence of dark matter is suggested not only by how stars orbit, but also by how galaxies cluster and how distant light bends around them in arcs of gravitational lensing. Everywhere astronomers look, the evidence repeats itself. Something unseen outweighs everything we see, something that does not shine, absorb, or collide in familiar ways, but still leaves an unmistakable trace in the way gravity flows. It is a reminder that most of the universe is hidden behind a veil, supporting what is visible without announcing itself. This thought changes the scale of reality. The stars, planets, and gas clouds that fill human imagination are not the main ingredients of the cosmos, but rather the ornament on a deeper structure. It is as though the most celebrated part of a building is the paint on the walls, while the beams and foundations, though unseen, are what truly keep it standing. Dark matter plays this role, shaping the architecture of galaxies and holding them together through cosmic time. Despite decades of searching, the true identity of dark matter remains a mystery. Some think it may be a new family of particles, others suggest it could be a deeper correction to the way gravity works. The answer is still out of reach, but the effect is certain. Galaxies shine brightly, but they are carried within dark halos that make their long lives possible. The unseen is not an absence, but the strength behind the lights in the sky. 3. Dark energy speeding up cosmic expansion. When scientists looked at the light from distant stellar explosions, they expected to find that the expansion of the universe was slowing down. Gravity should gradually pull everything back, slowing the outward drift of galaxies over time. Instead, they found the opposite. The expansion is accelerating as though space itself carries a gentle pressure that grows stronger over distance. This unknown agent has been called dark energy, not because it is ominous, but because it is mysterious and not yet explained. This discovery altered the view of the universe's future. If the expansion continues to accelerate, galaxies beyond a certain distance will move away faster than their light can ever reach us. In the far future, most galaxies will fade from sight, not because they vanish, but because the space between us stretches too quickly. Local groups may remain connected, but the larger landscape will grow empty and quiet, as if the universe were slowly drawing a curtain over its distant lights. The effect is not violent or sudden, it is slow and smooth, a steady drift that becomes obvious only when measured across billions of years. Yet the scale is immense. The fate of stars, galaxies, and clusters is written in the balance between matter, gravity, and this unseen energy that fills the vacuum. The whole cosmos is shaped by something so subtle it cannot be felt, yet so powerful it controls the largest structures of all. Research continues to map this acceleration with precision, comparing how structures grow and how light travels across the cosmic web. The answer may lie in a new property of space itself or in deeper physics not yet imagined. Until then, the idea stands on its own. The universe does not merely expand, it expands with increasing speed, and that quiet acceleration determines the destiny of everything. Force, the great attractor tugging on our galaxy, says. Astronomers discovered that our galaxy, along with thousands of others, is drifting toward a region of space partly hidden behind the thick band of the Milky Way itself. This mysterious region has been named the Great Attractor, a gravitational basin formed by clusters and walls of matter that bend the motions of entire galactic groups. Its presence is not something the senses can feel, but its influence is seen in the steady drift of galaxies as though carried along by an invisible current. The Great Attractor is not a single object, but a vast structure composed of multiple concentrations of mass. When mapped in detail, the region reveals a web of galaxies and clusters, a hidden geography of gravity pulling from behind the curtain of our own galactic plane. Infrared and radio surveys, able to see through dust and gas, show that we are being drawn into a wider flow that connects vast regions of the universe in slow, inevitable movement. To picture this is to imagine a river beneath the night sky upon starry, a current that does not ripple the water but still carries every boat. The Milky Way itself is such a boat, sliding steadily in the company of many others, its direction set not by its own decision, but by the quiet slope of gravity and space. No matter how still the stars appear overhead, they are all being guided in a broad and unhurried drift. Future studies will reveal more about this region, identifying the exact concentrations of matter and the flows they create. Yet even without every detail, the idea is clear. The cosmos has hidden landscapes not of hills and valleys but of gravitational pulls, and within them entire galaxies travel like leaves caught in a wide breeze. The Great Attractor is not loud or sudden, but its quiet influence is enough to set our course. 5. Cosmic strings as ancient scars in space. Some theories of the early universe predict that as it cooled and settled into new states, imperfections could have formed in the very fields that shaped reality. These imperfections would not look like cracks in rock or glass, but would be far stranger, long and narrow filaments stretched across space itself. They are called cosmic strings, and if they exist, they would be thinner than an atom yet denser than mountains, scars from the youth of the cosmos written into its structure. Such strings would not shine or emit light, but their presence could bend the path of radiation passing near them like an invisible lens carved into space. They might also create subtle imprints on the background glow of the early universe, straight lines drawn faintly across the sky that only the most sensitive instruments could detect. Despite long searches, no unambiguous evidence has been found, but the idea lingers because it offers a way to connect the earliest instance of time to the universe we now see. The picture is haunting in its simplicity. Imagine space itself stretched and torn while still hot from its birth, leaving behind marks that never healed. These scars would endure silently, unchanging as galaxies rose and fell around them, reminders of the universe's first moments. They would not disturb stars or planets directly, but would remain part of the hidden architecture that underlies all things, silent witnesses that carry the memory of how everything began. If they are never found, that itself is a revelation, showing that the early cosmos settled more smoothly than imagined. But if even one trace is discovered, it would be like holding a fossil older than stars, a direct connection to the first seconds of creation. Whether they exist or not, the thought of them widens the imagination, turning the night sky into not just a view of stars, but perhaps also a canvas that still carries marks from the universe's birth. 6. Black holes that slowly evaporate. Black holes are often described as inescapable prisons, swallowing everything and giving nothing back. Yet theory suggests they are not eternal. They emit a faint radiation so weak it is almost undetectable, but real enough to make them lose mass over time. This process is unimaginably slow for the largest black holes, but it means that even these dark giants are not forever. They evaporate, leaking their substance into the universe until, after trillions of years, they finally vanish. The origin of this evaporation lies in the strange rules of quantum mechanics. At the boundary of a black hole, called the event horizon, empty space is not truly empty. Pairs of particles flicker into existence, and when one falls in while the other escapes, the black hole loses a tiny bit of mass. Over countless ages, these tiny losses add up. The hole glows faintly, not with fire but with the most delicate heat, invisible yet inexorable, a reminder that even the darkest objects cannot escape change. This fate transforms how endings are imagined. A black hole may begin with violence born from the collapse of a massive star or the merger of giants, but its death is quiet. It does not explode outward like a supernova. It fades, whisper by whisper, until nothing remains. This soft ending is unlike the fierce image usually painted, offering a picture of the cosmos that is not just about force but also about patience. Though no one will ever see a large black hole complete this process, the principle is profound. It shows that permanence is an illusion, even in the most extreme corners of the universe. Time wears everything down, sometimes not with storms or fire, but with the slowest of drifts. The night sky, filled with glowing stars and silent voids, also contains these hidden stories of endings so long and gentle that they escape ordinary thought. 7. Zombie stars that reignite after death. Stars are expected to end their lives in clear ways, either collapsing into remnants or exploding into brilliance. Yet nature sometimes defies these neat endings. Certain stars, after a partial explosion, manage to survive, continuing to shine with altered forms. These are sometimes called zombie stars, because they have already faced death once, yet continue glowing in ways that puzzle astronomers. The process often involves white dwarfs, the dense cores left after a star exhausts its fuel. Under certain conditions, instead of exploding completely, they undergo weaker outbursts that burn part of their material but leave the core intact. This remnant then stabilizes, altered but still alive, a survivor that should not exist according to the simplest scripts of stellar evolution. It is as if the universe allows exceptions, stars that bend the rules and continue their story in unexpected chapters. Their light carries unusual chemical signatures, revealing the mix of material stirred by the incomplete blast. Observers see remnants that look both familiar and strange, halfway between the expected and the surprising. These objects demonstrate that cosmic life cycles are more diverse than once thought. Endings can be messy, recoveries possible, and survival not limited to the textbook paths. The idea is striking because it adds complexity to the otherwise rigid tale of stellar birth and death. It suggests that even in the realm of stars, where physics is strict and unforgiving, there is room for exceptions and second chances. The night sky is not filled only with predictable actors, but with characters that sometimes stumble, falter, and yet persist, quietly rewriting the rules of their existence. 8. Magnetars with mind-bending magnetic power. Among the strangest of stellar remnants are magnetars, neutron stars with magnetic fields so strong they defy ordinary comprehension. A magnetic field millions of billions of times stronger than Earth's can shape matter itself, stretching atoms into elongated forms and twisting the very fabric of empty space around them. These fields store enormous amounts of energy, sometimes released in sudden flares that momentarily outshine entire galaxies. The surfaces of magnetars are unstable, prone to starquakes that jolt their crusts and send shockwaves through space. When these quakes release magnetic energy, the results can be bursts of radiation so intense they saturate detectors on Earth, even from thousands of light years away. After the outburst, the magnetar returns to its eerie calm, spinning slowly, whispering faint pulses across the cosmos. Its rhythm is steady, its presence rare, its power hidden beneath silence. Despite their violence, magnetars exist in a state of long patience. They may flare once in centuries, then remain quiet, slowly aging as their magnetic fields weaken. Observing them is like glimpsing a storm frozen in time, holding more energy than can be imagined, yet releasing it only in brief flashes. Most of the time they are faint, almost invisible, but their very existence reveals the extremes of what matter can become. They remind us that the universe is not only vast in size, but also in range, pushing physical laws to limits far beyond ordinary experience. Magnetars are not common, but they are proof that nature experiments with possibilities that stretch imagination. Their quiet power is always present, waiting beneath the stillness of space, a reservoir of forces that rarely but memorably announce themselves. 9. Rogue planets drifting without a sun. Not all planets belong to solar systems. Some are ejected during the turbulent early stages of planetary formation, cast into the dark to wander alone through the galaxy. These rogue planets do not orbit stars. They drift endlessly, worlds without dawn or dusk, travelling through the night with no companion but their own silence. Estimates suggest they may be as numerous as the planets bound to suns, a hidden population of orphans adrift in the void. Without a star's warmth, these planets are cold, their surfaces frozen and still. Yet in their interiors, heat from formation or radioactive decay may linger, creating warm cores that could support subsurface oceans beneath thick crusts of ice. They are laboratories of isolation, places where life might survive in hidden layers, shielded from the endless dark. Though unseen with ordinary eyes, they are detected through their gravitational influence, bending light when they pass in front of distant stars. The image is haunting. Imagine a planet with mountains, valleys, and perhaps seas locked under ice, moving silently across the galaxy, never touched by sunlight. Its journey is endless and aimless, yet it continues, bound by no orbit, tied to no master. Such a world is invisible against the dark, and yet it exists. A reminder that planets are not limited to tidy solar families, but can also live in solitude. Discovering more of these wanderers will take time and better instruments, but their possibility alone changes how planetary systems are understood. Worlds need not circle a sun to be real. They can exist as solitary travellers, unlit but enduring, crossing the galaxy with no witness but the stars they pass. 10. Worlds where diamond rain may fall. On certain giant planets, pressure deep within the atmosphere is thought to be so extreme that carbon atoms are squeezed into crystalline form. In such conditions, diamonds may form and fall like rain, drifting downward in shimmering storms hidden beneath thick clouds. This is not speculation born from imagination alone, but an idea supported by the laboratory experiments and computer models that simulate the behavior of carbon under immense pressure. In these alien skies, methane molecules break apart, their carbon recombining into solid crystals that grow and descend. The rain would not glitter in sunlight, for these depths are dark, but the process itself would be steady and relentless. Each drop would carry the weight of precious stone, falling not as treasure, but as a natural part of the planet's weather, destined to melt or transform again as it sinks deeper into hotter layers. Such a cycle is strikingly different from Earth's familiar water cycle, yet it follows the same principle. The atmosphere shifts material from one state to another, recycling it endlessly in patterns determined by physics. On Earth it is rain, rivers, and oceans. On distant worlds it is diamonds forming, falling, and disappearing into depths where no eye will ever see them again. The ordinary becomes extraordinary simply because the stage is set differently. Even if direct proof remains difficult, the thought itself expands the imagination of what is possible. Weather is not limited to rain, snow, or wind. In the universe, entire planets may host skies filled with storms of jewels, hidden in darkness but real in principle. It is a quiet reminder that nature does not repeat Earth's script but writes countless others, each one as patient and continuous as the falling of rain. 11. Titan with seas of liquid methane. Titan, the largest moon of Saturn, carries landscapes that echo Earth but are built from different materials. Its surface is shrouded in thick orange haze, its temperature so low that water is solid as stone, yet methane and ethane flow like rivers and gather into wide seas. These lakes and seas form coastlines, deltas, and even waves under a dim golden sky. The atmosphere is dense enough for winds to push dunes across the plains, carving shapes over centuries, giving the moon a sense of restless motion. This hydrocarbon cycle mirrors Earth's water cycle in uncanny ways. Clouds gather in the sky, methane rains fall, rivers carve valleys, and liquids pool into basins that stretch for hundreds of kilometers. What would be exotic elsewhere is ordinary here, a system running in harmony under a faint sun. Radar images from spacecraft reveal smooth lakes that reflect signals like mirrors, proving the calm surfaces of these alien seas. From a distance, Titan seems quiet, yet beneath the haze it is active, a world with weather and geology that have never seen water or warmth as humans know them. The chemistry of Titan is particularly fascinating. Its atmosphere is rich in organic compounds produced when sunlight breaks apart methane and other molecules, leaving behind more complex hydrocarbons that drift down like snow. This constant rain of organic material covers the ground, feeding lakes and dunes with unfamiliar matter. The moon is a workshop where the chemistry of carbon plays out on a planetary scale, hinting at pathways toward complexity that could resemble the chemistry of early Earth. Future missions plan to explore Titan more closely, perhaps sending flying drones to drift above the dunes and coastlines. Each new look deepens the sense of wonder, showing a moon that is not just frozen and barren, but alive with cycles and flows. Titan is proof that worlds need not resemble Earth to be dynamic. In its deep cold, it sustains seas of liquid hydrocarbons, a reflection of what nature can do when conditions follow a different script. 12. Europa, hiding a deep salty ocean. Beneath the icy shell of Jupiter's moon, Europa lies an ocean larger than all of Earth's combined, kept liquid by the gentle heat of tidal forces. As the moon flexes under Jupiter's pull, its interior warms, preventing the water from freezing solid. The outer shell of ice is scarred with cracks and ridges, suggesting that it shifts and moves, evidence that the ocean below is active. To look at Europa is to see a surface of fractured white, but beneath it hides a world of water in constant motion. Hints of what lies below come not only from surface markings, but also from the chemistry detected on the ice. Salts have been identified, possibly carried upward from the ocean through cracks or geyser-like plumes. Some telescopes have even suggested faint sprays erupting into space, releasing traces of what lies beneath. If confirmed, these plumes would allow direct sampling of the hidden ocean without drilling, offering a glimpse of an environment that may be one of the most promising places to search for life. The ocean of Europa may resemble Earth's deep seas where sunlight never reaches, yet life thrives around hydrothermal vents. On Europa, heat from the rocky interior could create similar conditions, with minerals and chemical gradients providing the raw material for ecosystems. If life can exist in such a place, it would show that biology is not tied to sunlight alone, but can emerge wherever water, energy, and chemistry meet. The possibility stretches imagination without needing exaggeration. Future missions will approach Europa with instruments designed to taste the surface and search for signs of activity, even without direct evidence of life, confirming the depth, salinity, and chemistry of this hidden ocean will expand understanding of what kinds of worlds can host seas. Europa is a reminder that oceans may not be rare, and where oceans exist, possibilities widen. The quiet moon circling Jupiter may hold a secret vast and enduring waiting beneath its bright icy skin. 13. Saturn's rings younger than dinosaurs. Saturn's famous rings, admired for their beauty and symmetry, may be far younger than the planet they encircle. While Saturn itself has existed for billions of years, the evidence suggests its rings may have formed only a few tens of millions of years ago, younger than the last age of dinosaurs on Earth. Their composition of mostly clean ice hints at a recent origin, because over longer periods cosmic dust would have darkened them, leaving visible signs of age. The rings are not a solid structure, but billions of icy fragments ranging from tiny grains to house-sized boulders, all orbiting Saturn in delicate balance. Moons near the edges shepherd the particles, carving gaps and creating sharp boundaries, whilst gravity from Saturn shapes the larger patterns into bands and waves. From a distance they appear smooth and continuous, but up close they are a vast dance of icy debris in constant motion. The possible origin of the rings is dramatic. They may have formed when a moon ventured too close to Saturn and was torn apart by tidal forces, its remains spreading into orbit. Another idea suggests a comet or icy body broke apart, leaving fragments that gradually formed into the rings we see today. Whatever the cause, the rings are a temporary phenomenon, destined to thin and fade over millions of years, their brightness a fleeting phase in the life of the planet. Though temporary, their presence is breathtaking. To know they may not last forever makes them even more striking, a cosmic show that Earth happens to witness during its brief span of history. The rings encircle Saturn like a crown of ice, a structure both fragile and vast, revealing how destruction and beauty can emerge together in the mechanics of the cosmos. 14. Vast cosmic voids between galaxy walls. The large-scale structure of the universe is not evenly filled with galaxies. Instead, galaxies gather along filaments and walls, forming a cosmic web that stretches across billions of light-years. Between these walls lie immense regions nearly empty of matter, called cosmic voids. These voids are not absolute nothingness, but compared to the dense clusters that define the web, they are deserts of space, places where galaxies are rare, and distances between them stretch vast and silent. Voids form naturally as gravity draws matter into denser regions, leaving behind expanses where little remains. They can be hundreds of millions of light-years across, dwarfing the scale of any structure humans can imagine. Observations of these voids help measure the universe's expansion because their shapes are sensitive to the influence of dark energy and gravity. They are not only empty regions, but also tools for understanding the cosmos. The image of a cosmic void is haunting in its calmness. Within it, the usual crowding of galaxies falls away, and the stars become lonely markers scattered across deep darkness. A single galaxy may dominate the entire region, shining faintly with no neighbours nearby. To picture such a place is to imagine silence on a scale larger than clusters, emptiness that carries meaning not by what is present, but by what is absent. Though they may seem desolate, voids are just as important as the filaments that surround them. They show that the universe is not uniform, that structure emerges from contrast, and that even absence has a role in shaping the whole. The cosmic web is as much about the empty spaces as the crowded ones, a pattern drawn by both presence and silence together. 15. The oldest star nearly as old as time. Among the billions of stars in the Milky Way, a few stand out because of their extreme age. One particular star has been measured to be nearly as old as the universe itself, formed soon after the first elements emerged from the Big Bang. Its light is faint and steady, its chemistry simple, lacking heavy elements that only later generations of stars produced. This star has survived quietly for almost the entire history of the cosmos, a patient witness to everything that followed. The star is not massive, which is the secret to its longevity. Larger stars burn brightly and die quickly, but smaller stars sip their fuel slowly, stretching their lives across billions of years. This particular ancient star avoided the violence of collapse and explosion by simply lasting, shining gently while galaxies assembled, planets formed, and civilizations came and went. It is an elder in the truest sense, older than any human imagination of time. Its chemical composition tells a story. With almost no elements heavier than helium, it is a relic of a simpler cosmos, when only hydrogen and helium were common. Later stars added heavier elements through fusion and explosions, enriching the galaxy, but this star carries the signature of a universe still young and plain. It is like a page preserved from the very beginning, unchanged and enduring. To look at such a star is to look back almost to the dawn of everything. It proves that some lights can last nearly as long as the universe itself, shining without drama, needing no spectacle to prove their importance. Its survival shows that longevity comes not from strength or speed, but from restraint, a lesson written across the sky by a star, almost as old as time itself. 16. The early universe as a glowing fog. In its earliest ages, the universe was not transparent. It was filled with a hot plasma where light could not travel freely, scattering constantly off electrons and protons. This state made the cosmos a glowing fog, bright but impenetrable, hiding the formation of structures within. Only when the universe cooled enough for atoms to form did the fog clear, releasing the first light that could travel unimpeded. That light still fills space today as the faint background glow detected by modern instruments. This moment, called recombination, transformed the universe from opaque to transparent. In a single shift, the cosmos went from a misty sea of particles to a clear expanse where light could cross billions of years. The background radiation that was released then has stretched and cooled over time, becoming the cosmic microwave background, a faint echo of that ancient fog. This light carries tiny ripples, patterns of slightly hotter and colder regions that later grew into galaxies and clusters. The picture of the early universe as a glowing fog is vivid. It was not blackness after the Big Bang, but brilliance without clarity, light filling space without direction, a blaze with no view. Only as it cooled did shapes appear, like a mist lifting from a valley to reveal the landscape beneath. The fog was temporary, but its memory is permanent, preserved in the radiation that reaches us from every corner of the sky. By studying this background, astronomers learn not only about the first light, but also about the conditions that gave rise to everything since. The fog left fingerprints in its patterns, hints about the density, expansion, and geometry of the cosmos. The night sky may look sharp now, but it began in a haze, a universe that was bright everywhere yet showed nothing clearly until the fog finally thinned. 17, the first stars as colossal beacons. When the fog cleared and the universe became transparent, the first stars ignited. These stars were unlike those seen today, far more massive, burning hotter and brighter, and living short, violent lives. Without heavy elements to cool their gas, they grew enormous before collapsing in spectacular deaths, seeding space with the first metals. Their light rayonized the surrounding cosmos, ending the Dark Ages and beginning a new chapter of clarity. Because they lived quickly, they are no longer present. Their existence is known only through indirect evidence, the imprints they left on the gas around them and the chemical traces in later generations of stars. These first giants were the sparks that transformed the universe, providing both light and the elements that would later form planets, oceans, and life. Their brilliance was brief, but their influence continues in every atom of carbon, oxygen, and iron. To imagine the first stars is to picture lighthouses on a black sea, burning with unmatched power, visible across immense distances. They changed their environment not quietly but dramatically, flooding it with ultraviolet light, carving bubbles in the surrounding hydrogen and marking the end of cosmic silence. Their glow was the first chorus in a universe that had been dark and still. Modern telescopes aim to catch glimpses of their ancient light, stretched and dimmed by time. Whether or not they are seen directly, their role is certain. The first stars were beacons that signaled the transition from darkness to structure, beginning the long sequence of events that led to galaxies, solar systems, and eventually to the observers who now wonder about them. 18. Stars richer in helium than hydrogen. Most stars form from clouds dominated by hydrogen, with helium as the second most common ingredient. But some rare stars are different, containing far more helium than hydrogen. These unusual stars have histories shaped by mass loss, collisions, or interactions with companions that strip away their outer layers, leaving helium-rich cores exposed. Their light is hotter and bluer, and their lives run on shorter schedules, burning faster through their limited fuel. The spectra of these stars reveal their odd chemistry, with helium lines dominating instead of the usual hydrogen signatures. This marks them as outliers, a reminder that stellar evolution can take many paths depending on circumstance. They are rare but important, because they show how stars can be reshaped by violence, losing their hydrogen shells and exposing deeper layers. Each one tells a story of interaction, of past struggles and transformations. Their existence challenges simple models of how stars live and die. Instead of following the quiet path from birth to red giant to white dwarf, these helium stars may burn out faster, collapse sooner, or explode in unusual ways. They represent the diversity of stellar fates, the universe's refusal to follow only one script. Even the most basic assumption that hydrogen dominates every star has exceptions written across the sky. Studying them refines the broader understanding of stellar life cycles. Though they may not be common, they expand the picture of what stars can be, proving that the rules of the cosmos allow for more variety than once thought. Their bright blue light is both rare and telling, a clue that stars, like stories, come in more than one form. 19. Galaxies that shine mostly in infrared. Not all galaxies show their true brilliance in visible light. Some are wrapped in thick clouds of dust that absorb their starlight and re-emit it in infrared, a wavelength invisible to human eyes but detectable with the right instruments. These galaxies can appear faint or hidden when seen through ordinary telescopes, yet in infrared they blaze with activity, revealing star-forming regions hidden behind their veils of dust. This shift in wavelength reveals an entirely different view of the universe. Many of the most active galaxies, producing new stars at staggering rates, are invisible in visible light but dominate the infrared sky. Their dust cocoons act as both concealment and revelation, hiding their brightest regions yet also marking them with a glow that slips through the fog. Without infrared vision, entire chapters of cosmic history would remain unseen. Infrared observations show that galaxies are not uniform but layered, with different wavelengths telling different parts of their story. What looks calm and empty in one band may be busy and alive in another. These hidden galaxies remind us that perception is limited and that reality often thrives where eyes alone cannot reach. They are quiet teachers of humility, proving that what is overlooked may be the most important. Modern telescopes built for infrared have opened these secret worlds, mapping starbursts, dusty cocoons, and the growth of galaxies across time. Each discovery adds depth to the sky, showing that darkness is often an illusion, and that even where nothing is seen, light may be shining strongly in another register. The cosmos is far richer than the narrow slice visible to human sight. 20. Stars that sing with hidden vibrations. Stars are not silent spheres of gas. They vibrate with waves that ripple through their interiors, rising and falling in patterns that subtly change their brightness. These vibrations act like sound within a vast resonant chamber, turning each star into an instrument that plays a quiet but measurable song. By studying the timing of these oscillations, astronomers can learn about the internal structure of stars without ever touching them. Different stars produce different patterns of vibration, depending on their mass, age, and composition. Some pulse steadily, like simple drums, while others weave complex harmonies that reveal multiple layers within. These vibrations shift as stars age, their rhythms changing with the slow transformation of their cores. What looks like a single steady light is in truth a living rhythm, a voice that carries information across light years. This technique, called asteroseismology, has transformed the study of stellar life cycles. From the vibrations alone, astronomers can measure ages, densities, and compositions, turning points of light into detailed models. The stars become not only sources of illumination but also storytellers, their rhythms carrying hidden knowledge about their past and future. Each star is a library written in waves, and careful listening opens its pages. The idea that stars sing changes how the night sky is imagined. Every point of light becomes a performer in a cosmic orchestra, each playing continuously, each keeping time with exquisite precision. Their songs are not heard by human ears but are real nonetheless, written in light and rhythm. The universe, when seen this way, becomes not a silent void but a place filled with endless subtle music. 21. Galaxies launching jets for millions of light years. Some galaxies host black holes at their centres that do more than swallow matter. As gas spirals inward, twisted magnetic fields can focus streams of particles into narrow beams that shoot outward at nearly the speed of light. These jets can pierce through the host galaxy and extend far into intergalactic space, glowing brightly in radio waves and X-rays. Their reach is so vast that they stretch for millions of light years, longer than the galaxies themselves. The jets carry enormous energy, shaping their surroundings on colossal scales. They heat the gas between galaxies, prevent clouds from cooling too quickly, and influence the birth of stars. What begins in the chaos near a black hole ripples outward to sculpt entire regions of space. Observations show lobes of energized plasma spreading out like wings, silent but immense, marking where jets have been active for millions of years. These cosmic engines defy ordinary comparisons. Imagine a machine no larger than a solar system affecting volumes larger than clusters of galaxies. The scale is staggering, yet the process is steady, powered by gravity's simplest rule. Matter falls inward, energy is redirected, and beams shoot outward, repeating for as long as fuel is supplied. The results are not explosions but continuous streams that maintain their form over astonishing distances. Telescopes continue to reveal more of these giant structures, tracing how they interact with the cosmic environment. Each discovery shows that galaxies are not isolated but connected through these immense outflows, their centers influencing the spaces far beyond their visible edges. The night sky hides these jets in wavelengths the eye cannot see, but they are there, quiet bridges of energy linking galaxies to the vast dark. 22. Quasars being with black hole engines. In the distant universe, some of the brightest objects are not stars or galaxies, but quasars, powered by black holes consuming matter at ferocious rates. As gas and dust swirl into the accretion disk, friction heats the material until it glows with energy that can outshine entire galaxies. These quasars, though small compared to galaxies, are visible across billions of light years, their brilliance carrying news from a universe still young. Their light tells stories of the past. Because they are so distant, observing them is like looking back in time, to eras when galaxies were still forming and black holes grew rapidly. Quasars mark the sites of growth and transformation, places where matter fell in so quickly that it lit up the cosmos. They appear as points, yet each one is a furnace billions of times brighter than a sun, shining not by nuclear fusion but by the release of gravitational energy. Quasars are not steady but flicker and vary, responding to the turbulent flows of material feeding them. This variability makes them cosmic lighthouses, changing in brightness as though pulsing with life. Their jets, when present, extend into space like colossal searchlights, adding to their influence. Though violent in origin, their glow travels calmly across space, reaching Earth as a faint flicker in a telescope's eye. The existence of quasars shows how small regions can dominate vast scales. A black hole a few light hours across can outshine stars spread over tens of thousands of light years. The contrast is startling, but it is part of the natural order of things. In the early universe, these blazing engines were common, shaping galaxies and contributing to the growth of the cosmic web. 23. Pulsars that keep cosmic time. When massive stars collapse into neutron stars, some begin to rotate with incredible speed, sending beams of radiation outward like cosmic lighthouses. These are pulsars, and they spin with such precision that their flashes arrive with the accuracy of atomic clocks. Some rotate hundreds of times per second, yet never miss a beat, keeping time across millions of years. The mechanism is simple yet profound. A magnetic field channels particles along its poles, creating beams of radiation that sweep across space as the star spins. If Earth happens to lie in the path of those beams, telescopes detect regular pulses like the ticking of a cosmic clock. Their reliability is so great that pulsars have been used to test fundamental physics and even to map the galaxy with natural signals. Each pulse is the heartbeat of a dead star, a reminder that even in collapse, stars can persist with new roles. The regularity is eerie and comforting at once, as though the universe itself has built a metronome. While most stars fade quietly, pulsars announce themselves rhythmically, voices from remnants that refuse silence. They are cosmic reminders that time can be measured in flashes of light as well as in orbits and calendars. Their discovery transformed astronomy, opening a new way to study matter at extremes. Neutron stars are dense beyond imagination, and their signals reveal details of physics that cannot be recreated on Earth. Every pulse is both a measurement and a message, carrying knowledge across space, a rhythm that continues unbroken for millions of years. 24. The Hubble Deep Field revealing hidden galaxies. When the Hubble Space Telescope stared for days into what looked like an empty patch of sky, the expectation was to see only faint stars or nothing at all. Instead, the image that returned was filled with thousands of galaxies, some so distant their light had travelled for more than 10 billion years. The discovery became known as the Hubble Deep Field, a window into the immensity of the cosmos hidden within what appeared blank. Each point of light in that image is not a star but an entire galaxy, filled with billions of stars of its own. The realization is humbling. What the eye sees as emptiness is in truth crowded with worlds. Far beyond the capacity of human senses, the universe is not sparsely populated but overflowing. Every tiny patch of sky containing countless galaxies if only one looks deep enough. The image also provides a timeline. The most distant galaxies captured in the deep field appear as they were when the universe was only a fraction of its current age. Looking at them is like looking back in time, seeing galaxies at their infancy, still small and irregular, just beginning their long growth. The photograph is both a snapshot and a history lesson showing the story of cosmic evolution across billions of years. The lesson is simple but profound. Emptiness is an illusion created by limited vision. With patience and the right tools, the universe reveals richness where none was expected. The Hubble Deep Field remains one of the most important images in astronomy, not because it is beautiful, but because it shows that even the quietest patch of sky is alive with galaxies. 25. The Boomerang Nebula as a natural deep freeze. The Boomerang Nebula, a cloud of gas surrounding a dying star, is the coldest known place in the universe outside of artificial laboratories. Its temperature drops below 1 degree above absolute zero, colder than the background glow left from the Big Bang itself. The extreme chill is created by gas expanding so rapidly that it cools beyond the ordinary limits of space. The nebula's shape, captured in images, resembles a ghostly hourglass, streams of gas flowing outward at high speed. The expansion carries energy away so efficiently that the interior plummets to near perfect cold, a record in the natural universe. Despite being created by a dying star, it is not hot and fiery but silent and frozen, a paradox of heat turned into cold by the mechanics of expansion. To picture it is to imagine a furnace that burns so fast it chills, a star that creates the coldest region in existence by its dying breath. The contrast is startling, yet it is a natural outcome of physics, a reminder that extremes are not always where they are expected. In the depths of the cosmos, what looks like an ordinary cloud becomes the ultimate freezer. Studying the Boomerang Nebula offers insight into how stars lose mass and shape their surroundings at the end of their lives. It also provides an example of how familiar rules, like the cooling of expanding gas, scale up to cosmic proportions. The result is a nebula that is both striking in appearance and extraordinary in conditions, a natural deep freeze drifting in the silent dark. 26. Astronaut tears that refuse to fall. In the weightlessness of orbit, even the simplest experiences behave differently. Tears, for example, do not fall down a cheek as they do on Earth. Instead, they cling to the skin, forming shimmering spheres of water that grow larger as more fluid joins them. Without gravity to pull them downward, the tears remain stuck until wiped away or shaken loose. It is a small but profound reminder of how deeply life depends on gravity. Astronauts describe the sensation as strange, with tears building up in the corners of the eyes and sometimes floating away in droplets. Even crying in space becomes an unfamiliar act, transformed by the absence of weight. The body continues to produce tears for emotion or irritation, but the way they behave changes completely. The ordinary act of weeping becomes alien, a quiet example of life adapting to a new environment. The behavior of fluids in microgravity has practical implications. Sweat, condensation, and spills all act differently, spreading in unexpected ways, clinging to surfaces, or forming floating spheres. Understanding these effects is vital for designing spacecraft systems, from air circulation to water recycling. Tears are only the most personal example of a broader truth. Without gravity, even the simplest physics takes on unfamiliar forms. This small detail is often remembered because it humanizes the grand scale of space exploration. Beyond rockets, orbits, and distant stars, there are small moments where everyday life must be relearned. Crying without falling tears is one such moment, an intimate demonstration that in space, even emotions are touched by physics. 27. The Milky Way center flaring like a heartbeat. At the heart of the Milky Way lies a supermassive black hole, Sagittarius A, surrounded by swirling stars and gas. Though usually quiet compared to active galaxies, it sometimes emits bursts of X-rays that flare and fade, as though pulsing like a faint heartbeat. These flares are thought to come from material falling inward, heating and glowing briefly before vanishing across the horizon. The activity is unpredictable, with some flares lasting only minutes, while others continue for hours. Observations reveal that the black hole, though dormant most of the time, is not entirely silent. It breathes in bursts, moments of activity that ripple outward before returning to calm. The contrast between long silence and sudden outburst gives the center of the galaxy a rhythm, subtle but persistent. These flares are not destructive to the galaxy at large, but they remind us that the core is alive. The stars orbiting near Sagittarius A move at incredible speeds, proving its mass, while the occasional flare offers a glimpse of the processes at work near the edge of the abyss. It is as if the galaxy's heart, invisible and black, occasionally beats with light. Future instruments will study these events in greater detail, hoping to learn how matter behaves in the most extreme gravitational fields. Each flare adds a clue, but the overall pattern is clear. Even in apparent stillness, the center of the Milky Way carries a pulse, faint but real, marking the hidden life of our galaxy's core. 28 planets with the years that last only hours. Among the thousands of planets discovered orbiting distant stars, some circle so close to their suns that their years last only a few hours. These worlds are locked in tight orbits skimming the surfaces of their stars, enduring heat intense enough to vaporize rock and metal. Their atmospheres, if they exist at all, are blasted into space, leaving bare surfaces exposed to constant radiation. These ultra-short-period planets are unlike anything in the solar system. Their proximity to their stars makes them difficult to explain, as they must have migrated inward after forming farther out. Some may even be the stripped cores of larger worlds, their outer layers boiled away by the relentless heat. What remains is a scorched remnant, orbiting endlessly in a dance too close for comfort. The conditions on such worlds are beyond extremes. Day and night may not exist, as they are tidally locked, with one side facing eternal daylight and the other endless darkness. Surface materials may melt and vaporize, forming transient atmospheres that come and go with the orbit. From afar, they appear as tiny flickers in starlight, detected by the dips they cause when crossing their suns. Their discovery shows the diversity of planetary systems, proving that nature produces worlds stranger than imagination often allows. While inhospitable, they expand the understanding of what planets can be, filling out the spectrum from frozen giants to scorched embers. Each one is a reminder that the universe writes more varied scripts than the solar system alone suggests. 29. Black holes spinning near the limit of light. Black holes are defined by their mass, but many also spin. Some rotate so rapidly that their edges approach the speed of light, dragging space-time around them in extreme ways. This spin adds energy to the system, affecting how matter falls in, how jets are launched, and how nearby space is shaped. The fastest spinning black holes push physics to the edge, where rotation and gravity combine into extremes that strain understanding. Spin measurements come from observing the disks of hot gas that circle black holes. The inner edge of these disks is influenced by how fast the hole turns, and by analysing the radiation emitted, astronomers can infer the spin rate. Some black holes have been found rotating at nearly the maximum allowed by physics, just shy of breaking the limits of relativity. These giants are the most efficient engines in the universe, converting matter into energy with unmatched power. The effects are profound. Fast spin can twist magnetic fields, fueling jets that reach across galaxies. It can also stretch and warp the fabric of space so strongly that time itself behaves differently near the horizon. Falling towards such a hole is not only a matter of being pulled inward, but also of being caught in a whirlpool of space-time, spiraling toward an unavoidable end. These spinning titans remind us that black holes are not passive, they're dynamic, active, and capable of shaping their surroundings through more than gravity alone. Their extreme spins add complexity to their already strange nature, making them some of the most fascinating objects in the cosmos. 30. Planets hotter than some stars. Not all planets are cold or mild. Some orbit so close to their stars that their surfaces reach temperatures higher than those of cooler stars. These hot Jupiters and lava worlds are blasted by radiation, their atmospheres swollen and sometimes stripped away, their surfaces glowing with heat. They are planets in name but resemble furnaces in reality, places where metals can vaporize and winds of vaporized rock sweep across the sky. These worlds challenge the very definition of planet. With temperatures reaching thousands of degrees, their chemistry and physics operate in regimes unknown on Earth. Clouds of exotic minerals may form in their atmospheres, raining droplets of molten iron or glass. The heat distorts their shapes, inflates their atmospheres, and drives winds faster than any hurricane ever recorded. Despite their harshness, these planets are valuable laboratories. By studying their light, astronomers learn how atmospheres respond to extreme conditions, how elements behave under intense radiation, and how planets interact with their stars. Each observation expands the understanding of planetary science, showing that worlds are not limited to familiar conditions. The existence of planets hotter than stars proves that nature's range exceeds expectations. It is not only stars that burn with searing heat. Planets too can become infernos, living in orbits so close that survival takes on unfamiliar forms. Their presence broadens the spectrum of worlds and reminds us that the cosmos is filled with extremes that rewrite categories. 31. Moons orbiting asteroids in miniature systems. Not all asteroids travel alone. Some are accompanied by tiny moons, companions that orbit their rocky hosts in miniature versions of planetary systems. These moons can be discovered when the brightness of the asteroid dips as the moon passes in front, or by spacecraft that reveal their presence up close. They are small, often just a few kilometers across, yet they show that even the simplest objects in the solar system can form families. The existence of asteroid moons reveals the complex history of collisions and captures. A strike may throw material into orbit, where it gathers into a moonlet, or gravitational interactions may trap a passing rock. Over time, these companions settle into stable paths, circling quietly while their parent asteroid moves through space. Some asteroids even host 2 or more moons, making them tiny worlds with systems of their own. Studying these small systems helps refine understanding of gravity on the smallest scales. The orbits of moons around asteroids show how weak but persistent forces shape motion, echoing the same principles that guide planets and stars. These moons also provide insight into the structure of asteroids themselves, hinting at whether they are solid rocks or loose piles of rubble barely held together by gravity. For exploration, asteroid moons are important. Future missions may target them as stepping stones, laboratories, or resources. They prove that even the smallest bodies in space carry complexity. A simple rock may become the center of a system, showing that companionship is written across scales, from galaxies to grains. 32. The moon slowly drifting away. The Earth's moon is not fixed in place. Each year it drifts a few centimeters farther from Earth, pushed away by the tidal interactions between planet and satellite. This process has been measured directly by lasers bounced off reflectors left on the lunar surface. The measurements are precise, confirming that the moon is gradually slipping away, changing the dynamics of the Earth-Moon system over time. This drift is caused by tides. As the moon raises bulges on Earth's oceans, the rotation of the planet pulls those bulges slightly ahead. Gravity then transfers energy from Earth's spin to the moon's orbit, slowing Earth's rotation and pushing the moon outward. It is a delicate trade, invisible in daily life but profound over millions of years. In the distant past, the moon was closer, looming larger in the sky and causing stronger tides. In the distant future, it will be farther away, its pull weaker. The consequences reach far beyond orbital mechanics. Earth's rotation lengthens as energy is lost, meaning days have gradually grown longer since the planet's youth. Fossil evidence even confirms this, showing ancient corals that recorded more days in a year than exist now. The moon's slow retreat is a story written not only in mathematics but also in stone. Though the change is tiny each year, the long-term arc is dramatic. One day, total solar eclipses will no longer occur because the moon will appear too small to cover the sun completely. The familiar balance of Earth and moon is not eternal, but part of an ongoing dance, a reminder that even the most constant features of the sky are slowly shifting. 33. The North Star changing over the ages. The star known as the North Star Polaris has not always held its title, nor will it keep it forever. Earth's axis wobbles slowly like a spinning top, a motion called precession, and over thousands of years the direction of the pole drifts across the sky. This means that different stars take turns as the guiding star at the pole, while others fall away. Polaris is only the current holder of this ancient role. In the past, other stars served as the North Star. Around 3000 BCE, the bright star Thuban in the constellation Draco marked the pole. In the far future, stars like Vega will take the role, shining in the northern sky as the pivot around which the heavens turn. The shift is slow, taking thousands of years, but it is steady and inevitable, part of the long rhythm of Earth's motion. The knowledge of this cycle connects history and astronomy. Ancient builders aligned monuments to the stars they knew, and the drifting pole explains why some alignments now appear off. The heavens are not fixed but gently turning, carrying the markers of navigation with them. Polaris may be famous today, but its reign is temporary in the vast measure of time. The story of the shifting North Star shows that even seemingly eternal guides are part of a larger motion. Nothing in the sky is permanent, not even the points used for direction. The axis of Earth draws a slow circle in the heavens, and across millennia the title of North Star changes hands, a cosmic relay race carried out in silence. 34. Venus turning backward in slow motion. Venus spins in a direction opposite to most planets, rotating backward compared to its orbit. Even stranger, its rotation is so slow that a day on Venus lasts longer than its year. This means the sun rises in the west and sets in the east, but only after long stretches of time. While the planet completes its orbit around the sun, more quickly than it spins once. The reason for this unusual behavior is still debated. One possibility is that early in its history, Venus suffered a massive collision that altered its spin. Another is that tidal interactions with the Sun gradually reversed and slowed its rotation. Whatever the cause, the result is a planet where time behaves in unfamiliar ways, where the cycle of day and night is distorted beyond recognition. The consequences shape the planet's atmosphere. With such a slow rotation, winds dominate, circling the planet at incredible speeds and distributing heat. The surface bakes under a greenhouse atmosphere thick with carbon dioxide, while clouds of sulfuric acid swirl above. Despite its similarities in size to Earth, Venus is a world of extremes, its backward spin adding to its strangeness. To imagine standing on Venus is to imagine a world where the concept of a day is meaningless, where the sky brightens and dims over stretches longer than lifetimes. It is a reminder that planetary systems are full of variety, and that what is normal on Earth is only one version of how a planet can turn. By the way, if you like and subscribe to my video, this is the most effective way to support me. 35. The Milky Way orbit around itself taking 225 million years. The Milky Way is not still in space. It rotates, carrying the Sun and its planets along in a vast orbit around the galactic center. One complete journey takes about 225 million years, meaning the solar system has orbited the galaxy less than 30 times in its entire history. Each trip carries Earth through different regions of the galaxy, under different constellations and skies. During this orbit, the solar system passes through spiral arms, where star formation is active, and through quieter regions in between. The journey changes the environment, exposing Earth to different backgrounds of radiation and different neighborhoods of stars. Over geological time, these passages may even influence climate and evolution, though the effects are subtle and still studied. The scale of the orbit is almost impossible to grasp. At speeds of hundreds of kilometers per second, the Sun moves fast by human standards, yet the galaxy is so vast the journey takes hundreds of millions of years. While civilizations rise and fall, the solar system barely shifts its position along its path, showing the contrast between human time and cosmic time. To know that Earth rides this orbit is to see the sky differently. The constellations are temporary arrangements, visible for a short chapter in the long voyage. The galaxy itself is the greater frame, and each orbit is one beat in the slow heart of the Milky Way. 36. Galactic collisions, unfolding in silent slow motion. Galaxies do not remain isolated forever. They move through space pulled by gravity, and sometimes their paths intersect. When galaxies collide, stars rarely crash into one another, because space within galaxies is mostly empty. Instead, the collisions are of shapes and clouds, tidal forces pulling spirals into stretched arms and tails. Over billions of years, two galaxies may merge into one, reshaping their structure entirely. Though the word collision suggests violence, these events unfold in silence and slowness. Stars shift gradually, gas clouds compress, and new bursts of star formation ignite. From a distance, the merging galaxies look like dancers locked in embrace, their forms twisting and stretching before finally combining. The timescale is so long that what appears as a frozen image is in truth a living transformation still in progress. The Milky Way itself is destined for such a meeting. In a few billion years, it will collide with the Andromeda Galaxy, blending into a larger structure. From Earth's perspective, the night sky will slowly change, as Andromeda grows larger until it dominates the view. The collision will not destroy the galaxies, but merge them, weaving their stars into new patterns. Galactic collisions show that even the largest structures are not fixed. Change continues on every scale, from the flicker of particles to the dance of galaxies. The universe is dynamic, reshaping itself with time, and these immense mergers are its grandest choreographies. 37. Stars so huge they could engulf Saturn's orbit. While most stars are modest compared to the Sun, some are giants of almost unimaginable size. The largest known stars are so vast that if placed at the center of our solar system, they would extend beyond the orbit of Saturn. Their surfaces are diffuse, glowing tenuously, their atmospheres stretching across billions of kilometers. Despite their size, they are fragile, living fast and dying young. These hypergiants burn fuel at incredible rates, shining millions of times brighter than the Sun. Their cores are unstable, fusing elements rapidly, and their outer layers expand outward in swelling waves. Observations show them shedding mass through strong winds, surrounding themselves with clouds of gas and dust. They live in constant tension between gravity pulling inward and a pressure pushing outward. Their end is inevitable and violent. Hypergiants often collapse into supernovae, explosions so powerful they enrich galaxies with heavy elements and leave behind neutron stars or black holes. Their brief lives make them rare, but their influence is lasting, shaping the chemical history of their surroundings. Each one is a brief beacon, glowing with enormous power before vanishing in a final outburst. The sheer scale of these stars challenges imagination. To picture a single star encompassing planets across half the solar system is to grasp the diversity of stellar forms. Not all stars are steady and long-lived like the Sun. Some flare into existence as giants, live intensely and die spectacularly, leaving behind echoes in the material of future worlds. 38 gamma-ray bursts as lights that outshine galaxies. Among the most energetic events in the universe are gamma-ray bursts, flashes of radiation so powerful they can briefly outshine entire galaxies. These bursts last from fractions of a second to several minutes, releasing more energy in that time than the Sun will in its entire lifetime. They are thought to be caused by collapsing massive stars or the merger of neutron stars, events that channel energy into narrow beams aimed across space. The discovery of gamma-ray bursts surprised astronomers because they appeared suddenly and vanished quickly, leaving no trace. Satellites first detected them by accident, built to monitor nuclear tests on Earth. The bursts came from deep space, revealing a new phenomenon that was both rare and immensely powerful. Their origin became clearer only after years of study, connecting them to the most violent deaths of stars. Despite their destructive energy, gamma-ray bursts occur far enough away that they pose no danger to Earth. Their rarity in our neighbourhood means they are more valuable as windows into the early universe than as threats. The light they emit carries information about the environments where stars die and black holes are born, helping scientists piece together the cycles of matter and energy in galaxies. To imagine one is to imagine a lighthouse beam magnified to cosmic scale, sweeping across the universe for seconds, brighter than everything else combined. Though fleeting, their brilliance adds to the understanding of how extreme the universe can be, showing that even brief moments can carry immense weight. 39. Galaxies shaped as rings and ghosts. Not all galaxies fit the familiar spiral or elliptical forms. Some are ring galaxies, with bright circumferences of stars surrounding empty centers, formed when one galaxy passes through another and triggers waves of star formation. Others are faint and diffuse, ghostly structures barely visible against the background, containing few stars but stretching across vast regions. These unusual shapes show the creativity of gravity and time. Ring galaxies are striking in their symmetry, looking almost artificial. Their stars form along the expanding wave created by an intruder galaxy, leaving the core empty while the rim glows with new light. The process is temporary, but it produces some of the most photogenic structures in the sky. Ghost galaxies, on the other hand, lack such brightness. Appearing as shadows, their light spreads so thin that only careful observation reveals them. These forms are reminders that galaxies are not static objects but evolve through encounters and interactions. Their shapes can be twisted, bent and rearranged by collisions, leaving behind structures that defy neat categories. The universe is not limited to spirals and ellipses. It hosts rings, arcs, smudges, and faint whispers, each telling a story of the motion and chance. The variety of galactic shapes broadens the sense of what is possible. Gravity acts on every scale, and over billions of years it sculpts forms that surprise even experienced observers. Each strange galaxy is not an exception, but part of a larger pattern of creativity, proof that the cosmos is full of designs drawn slowly across the canvas of space. 40. Invisible particles flickering in vacuum. What appears to be empty space is not truly empty. Quantum theory predicts that even the vacuum is alive with activity, particles appearing and vanishing in pairs, flickering in and out of existence in times too brief to measure. These virtual particles cannot be seen directly, yet their effects are real, influencing forces and altering energy levels. The vacuum is less a void and more a restless sea of possibility. This constant flickering is known as quantum fluctuation. It underlies many phenomena, from the forces that hold atoms together to the seeds of structure in the universe. In the earliest moments after the Big Bang, fluctuations in the vacuum may have been stretched by cosmic inflation, growing into the ripples that later became galaxies. What began as tiny chance differences became the architecture of the cosmos. Though invisible, the presence of these particles has been confirmed by precise experiments. Effects like the Casimir force, where two plates in a vacuum attract each other, arise directly from the restless nature of empty space. These experiments prove that the vacuum is not nothing but a field buzzing with hidden energy. The idea is profound. Emptiness itself is full, a background that never stops moving. Even in silence and darkness, the universe hums with activity too subtle for the senses, but essential for existence. The vacuum is not the absence of everything, but the foundation on which everything rests. 41. Cosmic rays passing through every person. Every second, invisible particles known as cosmic rays pass through bodies, buildings, and landscapes without notice. These particles are fragments of atoms accelerated to near the speed of light by distant supernovae, black holes, and galactic events. When they strike Earth's atmosphere, they break into showers of secondary particles that cascade down to the surface. Each human is silently touched by thousands of these messengers from space, every moment of life. Their journey is astonishing. Cosmic rays can travel across entire galaxies, carrying energy released from events that happened millions of years ago. Some are deflected by magnetic fields, spiraling through space before reaching Earth. Others come almost directly, their paths only slightly bent, delivering information about their distant origins. They are silent travelers, reminders that the universe is not separate, but constantly interacting with the planet. The effects of cosmic rays can be both subtle and significant. They contribute to the background radiation of Earth, influence atmospheric chemistry, and even seed the clouds that drift across the sky. Technology feels their presence too, as sensitive electronics can register tiny disruptions caused by these energetic visitors. They are part of the hidden weather of space, invisible yet persistent. To realize that every moment is filled with such interactions changes how emptiness is perceived. The air is not empty, the sky is not distant. Cosmic rays arrive constantly, crossing skin, stone, and sea. They are gentle reminders of the universe's reach, carrying the signatures of events so far away they defy scale, yet still touching life in ways both quiet and continuous. 42. The universe without edges like a curved room. When imagining the universe, it is tempting to picture it as a sphere expanding into something larger. Yet modern cosmology suggests it may not have an edge at all, and instead the universe could be finite but unbounded, like the surface of a sphere that has no edge but still has limited area. In this picture, travelling far enough in one direction could, in principle, bring one back to the starting point, though on a scale beyond comprehension. This curved nature arises from general relativity, where mass and energy bend space-time. Depending on the total density of the cosmos, space can be curved positively, negatively, or nearly flat. Observations suggest the universe is astonishingly close to flat, but slight curvature is still possible, leaving open the question of whether the cosmos is truly infinite or loops back on itself. The concept is difficult to grasp because it has no direct analogy in daily life. A room without walls or edges yet finite in volume defies experience, yet mathematics shows it is possible. Space may be like a fabric stretched so smoothly that it appears flat locally, but globally it curves into a form with no boundary. This does not mean a wall exists somewhere, but that the notion of an edge may be meaningless. Whether infinite or curved, the lesson is the same. The universe is not like a balloon floating in larger space. It is space itself, structured by its own rules. To imagine walking forever without finding a boundary is to realize how far beyond human scale the cosmos stretches, a reality where edges and borders are not required. 43. The observable universe spanning 93 billion light-years. Though the universe is 13.8 billion years old, the observable portion is far larger than that age would suggest. Because space itself expands, light from the earliest galaxies has travelled across regions that have stretched away during its journey. The result is that the observable universe has a diameter of about 93 billion light-years, an immense sphere centred on Earth, but not limited to it. This size does not mean Earth is special. Every observer anywhere in the universe would see a similar sphere around themselves. bounded by the distance light has had time to travel since the Big Bang. What lies beyond is unknown, possibly infinite, possibly curved back upon itself, hidden forever because light has not had time to cross it. The observable universe is a horizon, not a limit, like the edge of vision on a vast plain. The immensity of this scale is difficult to absorb. Galaxies near the edge of visibility are seen as they were billions of years ago, their light stretched into faint red glows by expansion. What appears today as a faint smudge may no longer exist in the same form, its light only now arriving after a journey across cosmic time. Each photon is a messenger carrying news from eras long gone. The observable universe is both vast and personal. It defines the stage of all human knowledge, the theatre within which science and imagination can reach. Beyond it may be more galaxies, more structures, or perhaps infinite repetition. What is seen is already overwhelming, a bubble of 93 billion light-years filled with billions of galaxies, each carrying billions of stars. 44. The early universe almost smooth with tiny ripples. After the Big Bang, the universe was astonishingly uniform, with matter spread nearly evenly in every direction. Yet it was not perfectly smooth. Tiny ripples, differences in density of less than 1 part in 100,000 existed in the hot plasma. These faint variations were recorded in the cosmic microwave background, appearing as tiny spots of slightly different temperatures when mapped in detail. Though small, these ripples were the seeds of all future structure. Regions with slightly higher density attracted more matter, growing over billions of years into galaxies, clusters, and filaments. Without the faint irregularities, the cosmos might have remained a bland haze, with no stars or planets to give it texture. The entire universe of light and structure grew from differences so subtle they were almost invisible. The origin of these ripples is traced to quantum fluctuations stretched during cosmic inflation, the rapid expansion of the universe in its first instant. Random chance became permanent pattern, locked into the background radiation as a map of what would come. The simplicity of the beginning led to the complexity of everything that followed, a transformation from smoothness to structure. Looking at the night sky today is to see the result of those early ripples magnified billions of times. Every galaxy, every star, every world owes its existence to the tiny imperfections present at the dawn of time. The universe began almost smooth, but it was the imperfections that made it interesting, the flaws that gave birth to everything. 45. The heliopause where Voyager entered interstellar space. The Sun creates a bubble in space called the heliosphere, filled with the solar wind of charged particles flowing outward. At the edge of this bubble lies the heliopause, where the solar wind slows and is balanced by the pressure of interstellar space. Crossing this boundary means leaving the influence of the Sun's wind and entering the wider galaxy. The Voyager spacecraft, launched in 1977, became the first human-made objects to cross the heliopause. Instruments recorded the change in particle density and magnetic fields, confirming the transition from solar wind to interstellar medium. Though still within the Sun's gravitational influence, they had passed into a new region, one where the particles around them came not from the Sun but from the galaxy itself. The heliopause is not a sharp wall but a shifting boundary, moving inward and outward as the Sun's activity changes. Yet it marks a profound transition, the point where the Sun's immediate breath ends. Beyond lies the interstellar environment, a medium filled with cosmic rays, dust, and magnetic fields linking the galaxy. The spacecraft, small and fragile, drift onward into this greater sea. The crossing of the heliopause represents more than a scientific milestone. It is a symbolic step outward, the first time human artifacts have entered interstellar space. The Voyagers continue to send faint signals home, carrying news from a realm never touched before. They mark the beginning of humanity's presence beyond the Sun's protective bubble. 46. The center of our galaxy scented by complex molecules. Near the core of the Milky Way, astronomers have detected a surprising variety of complex molecules. Among them are compounds that produce scents familiar on Earth, such as the molecules that give raspberries their flavor and others that smell like rum. Though no one can breathe there, the chemistry of the galactic center is unexpectedly rich, a stew of molecules drifting in the dense clouds around the black hole. These molecules are identified by their spectral signatures, the unique fingerprints of light absorbed or emitted by different atoms and bonds. Radio telescopes scan the sky and pick out these signals, building catalogues of cosmic chemistry. The discoveries show that space is not sterile but full of organic compounds, some of them complex enough to resemble the building blocks of life. The galactic centre is a turbulent environment, with stars forming, dying and exploding in close quarters. Yet within the chaos, molecules survive and accumulate. Clouds of gas and dust shield them from the harshest radiation, allowing chemistry to proceed. What results is an interstellar kitchen, where molecules familiar to earthly senses drift silently in the void. The presence of such molecules suggests that the ingredients for life are widespread, scattered not just on planets but across entire galaxies. The heart of the Milky Way, though extreme in gravity and energy, still fosters the quiet assembly of complex chemicals. The universe carries flavour and scent, though in places no one will ever inhale. 47. Planets flung away as cosmic orphans. Not all planets remain bound to their stars. During the chaotic early years of planetary systems, gravitational interactions can fling planets outward, ejecting them into the galaxy as solitary wanderers. These rogue planets drift without suns, cold and dark, carrying their own lonely paths across interstellar space. The process of ejection is violent but natural. Large planets can scatter smaller ones, or close encounters with other stars can destabilize orbits. Once freed, these worlds no longer orbit anyone, continuing forever in solitude. They may be common, perhaps as numerous as the planets still orbiting stars, yet most are invisible, lost in the dark. Despite their isolation, rogue planets may still carry heat within. Some could have oceans trapped under ice, warmed by radioactive decay in their cores. Life, in theory, could survive in such hidden seas, cut off from starlight but sustained by internal energy. These possibilities widen the imagination, suggesting that habitability may not require a star at all. Detection of these planets is difficult, but gravitational microlensing offers a way, catching the brief bending of starlight as a planet passes in front. Each detection confirms that orphans exist, reminders that planetary systems are not permanent. Worlds are born, scattered and lost, carrying their silence across the galaxy without ever returning home. 48. The fastest known pulsar, spinning 716 times each second. Among neutron stars, some rotate with dizzying speed, sending out beams of radiation that flash in rapid pulses. The fastest known pulsar spins more than 700 times each second, completing a rotation in less time than a blink. Its precision is astonishing, maintaining this frantic pace steadily across years, each rotation timed like a perfect machine. The origin of such rapid spin lies in companionship. These pulsars are often part of binary systems where material from a partner star falls onto the neutron star, transferring angular momentum and spinning it up. The process turns a slow pulsar into a millisecond pulsar, whirling at extreme speeds. Despite the violence of their birth, these objects achieve remarkable stability. The signals from millisecond pulsars are so regular they rival atomic clocks. Astronomers use them to test theories of gravity, detect gravitational waves, and even consider them as natural navigation beacons for spacecraft. Each pulse is both a reminder of the star's incredible density and a gift of precision across the cosmos. The idea of a star spinning hundreds of times per second challenges ordinary sense, yet it is real, measured with certainty. These objects show that the extremes of nature are not only possible but persistent, continuing their rapid pace long after their dramatic formation. They are spinning relics, both violent in origin and steady in life. 49. The Big Rip as a possible cosmic finale. Among the many theories of how the universe might end, one of the most dramatic is the Big Rip. If dark energy grows stronger with time, its acceleration could increase until it tears apart galaxies, stars, planets, and even atoms. Space itself would stretch faster and faster until every structure is unbound, leaving only a thin soup of particles drifting in infinite expansion. The timeline for such an ending depends on the nature of dark energy. If it is constant, the universe will expand forever, but slowly enough for galaxies to remain intact. If it strengthens, the rip could occur in tens of billions of years. Long before the final moment, galaxies would drift beyond each other's reach. Stars would be stripped from systems, and eventually molecules would unravel. The idea is both terrifying and strangely elegant. Instead of collapse into a final singularity, the universe would dissolve into endless separation. No explosion or implosion, just stretching without limit until nothing remains bound to anything else. The structures that took billions of years to form would vanish in a fraction of that time. Though speculative, the Big Rip is one possibility among many. Its importance lies not in prediction, but in showing how much remains unknown about dark energy. The fate of the universe depends on the nature of this hidden force, a mystery that continues to shape cosmology. 50. The heat death when stars finally go dark. Another scenario for the end of the universe is the heat death, a state reached when all usable energy is exhausted. Stars will eventually burn out, galaxies will fade, and black holes will evaporate. Over trillions upon trillions of years, the cosmos will become cold, dark, and uniform, with no gradients left to power change. Time would continue, but events would cease. This vision of the future arises naturally from the second law of thermodynamics, which states that entropy, or disorder, tends to increase. As energy is spread more evenly, the ability to do work diminishes. Once all stars have spent their fuel and all matter has decayed or dispersed, the universe will thus reach equilibrium, a state of stillness where nothing more can happen. The scale is almost beyond imagination. Trillions of years after the last stars have faded, black holes will remain as the final structures. Yet even they will not last forever. Through evaporation, they too will vanish, leaving only a thin background of particles in expanding space. The universe will not end with a bang, but with a whisper fading into silence. Though distant beyond measure, the heat death carries lessons for the present. It shows that the universe has an arrow of time, a direction toward greater entropy, and that all activity from galaxies to thoughts depends on the temporary imbalance that still exists. The night sky shines because the universe is young enough to burn brightly, but the distant future is written in darkness. 51. Most of the universe hidden from human eyes. When gazing at the night sky, what is visible is only a thin slice of reality. Human eyes are sensitive to a narrow band of wavelengths, a sliver between infrared and ultraviolet. Beyond that lies a vast spectrum of radiation, from radio waves as long as mountains to gamma rays smaller than atomic nuclei. Most of the energy and information in the universe flows through these invisible ranges, unseen unless instruments are built to detect them. Radio telescopes reveal structures that appear silent to sight, mapping enormous diffuse jets and halos invisible in visible light. Infrared instruments uncover star-forming regions hidden behind clouds of dust, where new suns are born in secret. X-ray observatories find the violence of black holes and exploding stars, while gamma-ray detectors record the most powerful events the universe produces. Each new band of light opens a different world layered over the same sky. Even within the visible band, the majority of the universe is still hidden. Dark matter outweighs visible matter, unseen but fundamental. Dark energy, stranger still, dominates the cosmos without being observed directly. Together they form 95% of everything, leaving the familiar stars and galaxies as a small fraction of the whole. The human view of the universe is a tiny window in a vast mansion. Its other rooms locked but not empty. Recognizing these limits changes the sense of the night sky. The stars twinkling overhead are real, but they are only the decoration of something far larger and stranger. The universe is layered with signals and structures invisible to the senses, requiring patience and tools to reveal. To see only with eyes is to miss most of reality, yet with instruments and thought, the hidden universe slowly comes into focus. 52. Planets circling two suns. In many star systems, planets orbit not one star but two. These circumbinary planets travel around a pair of suns locked in their own mutual orbit. The sky from such a world would be unlike anything on Earth, with two suns rising and setting sometimes together, sometimes apart, painting the sky with changing patterns of light. Fiction imagined these worlds long before they were discovered, but telescopes have confirmed their reality. The orbits of these planets are complex but solvable. The twin stars act as a single gravitational source, and planets that orbit far enough away can circle both without being torn apart. Observations have revealed several such worlds, proving that binary systems, which are common in the galaxy, can host planets just as single stars can. The diversity of planetary systems expands far beyond what was once imagined. The conditions on these worlds would be extraordinary. Days could vary in length depending on the alignment of the suns, and temperatures could fluctuate as the stars shift in the sky. Seasons would not follow the same patterns as on Earth, instead shaped by the dance of two centers of light. These variations would create landscapes and climates unlike any seen before. The discovery of circumbinary planets proves that nature finds ways to build worlds under many conditions. Where there are stars, planets can form, whether around one, two, or perhaps even more. The night sky is not limited to Earth's script. It is broader, stranger, and richer, filled with possibilities beyond ordinary imagination. 53, Neptune's year, lasting 165 Earth years. Far from the Sun, Neptune circles in an orbit so vast that it takes 165 years to complete a single trip. This means that since its discovery in 1846, Neptune has only recently finished its first observed orbit. A year on Neptune is longer than any human lifetime, a reminder of how differently time passes in the outer solar system. The length of Neptune's year shapes its seasons, though they are difficult to observe from Earth. Each season lasts for decades, slow changes unfolding as the planet creeps around the Sun. The atmosphere, filled with methane that gives Neptune its blue colour, shifts with winds faster than any hurricane. Yet the larger cycle of light and darkness crawls at a pace too slow for immediate notice. Neptune's long orbit also shows the scale of the solar system. Distances are so vast that even at high speeds the planet drifts slowly, its position changing only slightly over the course of decades. While Earth hurries through its cycle in a single year, Neptune lingers, its calendar written in centuries. For any observer on its surface, the rhythm of time would feel entirely different, stretched into lifetimes of waiting for a single cycle to complete. The slowness of Neptune's orbit gives perspective on the human scale of time. Civilizations rise and fall in less than a Neptunian year. The planet continues its steady course, indifferent to the quickness of human history. Its long seasons and vast path remind that time is not a single measure, but changes depending on the world one stands upon. 54. Earth's atmosphere stretching beyond the Moon. The atmosphere of Earth is usually pictured as a thin shell hugging the planet closely, but in reality it extends much farther than most imagine. Recent measurements show that the outermost layer of hydrogen, called the geocorona, reaches more than 600,000 kilometers into space. This means Earth's atmosphere stretches well beyond the orbit of the Moon, enveloping it silently in a tenuous haze. This extended atmosphere is incredibly thin, almost a vacuum, but it still counts as part of Earth. Sunlight scatters off its hydrogen atoms, allowing instruments to detect it from space. For astronauts and spacecraft, it is effectively invisible, offering no resistance, yet it shows that Earth's influence reaches farther than the eye can see. The Moon itself orbits within Earth's extended atmosphere without anyone realizing it. The discovery redefines how the Earth is imagined. It is not just a rocky globe with a close air layer, but a body with an atmosphere stretching far into space, fading gradually rather than ending sharply. The planet's presence is larger, more diffuse, and more connected to the cosmos than once thought. The familiar blue sky is only the dense lower portion of something far broader. Knowing this adds to the sense of continuity between Earth and space. The atmosphere does not stop abruptly, but merges gradually into the interplanetary medium. The boundary between Earth and the cosmos is more porous, more blended than once believed. Even the Moon, thought of as a separate world, orbits inside Earth's unseen breath. 55. The Sun containing 99.8% of the solar system's mass. The Sun is not just the central light of the solar system, but its overwhelming weight. Containing more than 99% of all the mass, it dominates everything. Planets, moons, asteroids and comets together make up only a fraction. The Sun's gravity holds them in orbit, its heat drives their climates, and its light powers their chemistry. The solar system is not balanced between Sun and planets. It is almost entirely the Sun. This mass is concentrated in a sphere of plasma, fusing hydrogen into helium at its core. The energy released in this fusion flows outward, taking thousands of years to reach the surface, then travelling as light and heat across space. Every breeze, every wave, every living thing on Earth depends on this steady outflow of energy, the product of the Sun's vast weight and gravity. The dominance of the Sun explains why the planets move as they do. Their orbits are determined not by their own mass, but by the overwhelming pull of the Sun. Even giant Jupiter, the largest planet, is a tiny fraction in comparison, The Sun is both the anchor and the furnace, holding the system together while fueling its warmth. Recognizing this scale shifts the sense of importance. The planets are intriguing, but they are ornaments around a massive star. The true bulk of the system lies in the glowing sphere at the center. The solar system is, in essence, a star with small companions, not a collection of equal partners. 56, the great red spot older than human civilization. On Jupiter, a storm larger than Earth itself has been raging for centuries. Known as the Great Red Spot, it is an anticyclonic system of swirling winds that has persisted since at least the 17th century, when telescopes first recorded it. This makes the storm older than modern human civilization, a continuous weather event outlasting empires and generations. The storm's winds reach hundreds of kilometers per hour, circling in a vast oval that shrinks slowly over time but remains immense. Its color, ranging from brick red to pale pink, is influenced by chemicals in Jupiter's atmosphere reacting with sunlight. The exact cause of its hue is still uncertain, adding mystery to its already impressive endurance. Despite its ferocity, the Great Red Spot is not static. It shifts in shape, size, and intensity, sometimes growing, sometimes fading, but never disappearing. It is fed by Jupiter's turbulent atmosphere, where heat from the planet's interior drives constant storms. The spot has become a symbol of the planet, a reminder that weather on other worlds can be measured in centuries rather than days. The scale of this storm contrasts sharply with the briefness of earthly weather. Hurricanes last weeks at most, but Jupiter's great storm has lasted lifetimes. It shows that planetary conditions vary wildly across the solar system, producing extremes far beyond human experience. The Great Red Spot is not just a storm, but a monument to persistence in a restless atmosphere. 57, Mars once flowing with rivers and seas. The dry, dusty surface of Mars was not always so barren. Evidence shows that billions of years ago, water once flowed across its surface, carving valleys, filling lakes, and perhaps forming a vast northern ocean. Riverbeds can still be traced, their patterns unmistakable, while minerals formed in water lie scattered across the landscape. Mars carries scars of a wetter past, reminders of an era when it was more Earth-like. Images from orbit reveal deltas and alluvial fans, features that form when water deposits sediment. Rovers on the ground have found pebbles rounded by flowing streams, proof that liquid water once moved with force. The atmosphere was thicker then, holding enough pressure and warmth to sustain lakes and seas. Mars was not always a frozen desert. It was once a world of blue as well as red. The mystery is what happened to this water. Over time, the atmosphere thinned, perhaps stripped by the solar wind when Mars lost its magnetic field. Without pressure, water could not remain liquid, and this planet dried. Some water froze underground or at the poles, while much escaped into space. The transformation left Mars cold, dry, and silent. Yet the evidence of its wet history raises the possibility that life once had a chance there. If microbes evolved in those ancient lakes, traces may remain in rocks or soil. The search for such fossils continues, with each mission adding to the picture of a world that was once more hospitable. Mars today is dry, but its past still whispers of rivers and seas. 58, Saturn light enough to float on water. Saturn, with its magnificent rings and vast size, is paradoxically less dense than water. If there were a cosmic ocean large enough, Saturn would float. Its bulk is made mostly of hydrogen and helium, light gases compressed by gravity into a planet that looks massive, but is relatively airy. The result is a giant so big it could contain more than 700 Earths, yet still light enough to float in principle. The low density shapes Saturn's character. Its atmosphere is layered with clouds of ammonia and methane, while deeper layers press hydrogen into metallic forms. Beneath it all lies a small, rocky core, surrounded by immense envelopes of gas. The contrast between its volume and its density makes it unique among planets, an enormous world with the buoyancy of something far smaller. This strange fact highlights the diversity of planets. Mass and size do not always correlate with heaviness. A planet can be huge and light, or small and dense, depending on its composition. Saturn shows that appearances can be misleading, a giant with the heart of a feather compared to rockier worlds. Imagining Saturn floating in water is the playful thought experiment, but it carries serious lessons. It demonstrates how physics allows a wide range of planetary structures, reminding us that even familiar giants are stranger than they appear. Saturn is not just a ringed beauty, but also a paradox, a giant too light for its size. 59, time flowing differently on the International Space Station. Einstein's theories of relativity reveal that time is not absolute. The faster an object moves or the stronger the gravity it experiences, the slower time passes for it compared to others. Astronauts aboard the International Space Station, orbiting Earth at high speeds, experience this effect. Their clocks tick slightly slower than those on the surface, meaning they age a tiny bit less during their missions. The difference is small, only fractions of a second over months, but it is real and measurable. Precision instruments confirm that time aboard the station does not match time on Earth. Gravity also plays a role, as astronauts are farther from Earth's center and experience slightly weaker gravity, which makes their time run faster. The two effects nearly balance, but speed dominates, leaving time aboard the station a touch slower. These differences may seem trivial, but they prove a profound truth. Time is not universal. It bends and shifts depending on motion and gravity. Every orbit of the station is a demonstration of relativity, carried out not in equations but in lived experience. The astronauts return home having aged ever so slightly less than those who stayed. Though the effect is small, it has practical applications. Systems like GPS must account for relativity to function correctly, adjusting for differences in time between satellites and Earth. The cosmos does not follow human clocks. Time itself is part of the fabric of space, flowing at different rates depending on the path taken. 60, Jupiter's magnetic field stronger than all others. Jupiter possesses the strongest magnetic field of any planet in the solar system, a field so powerful it dwarfs Earth's. It is generated by the movement of metallic hydrogen deep within the planet, where pressures crush hydrogen into a conductive state. This dynamo creates a magnetosphere so large it stretches millions of kilometers into space, enveloping many of Jupiter's moons and dwarfing the planet itself. The magnetic field traps charged particles, creating intense radiation belts that would be lethal to unprotected spacecraft. It also powers immense auroras, larger than Earth itself, glowing at Jupiter's poles as particles spiral along magnetic lines and collide with the atmosphere. These auroras are permanent features, fueled not only by the solar wind, but also by particles from Jupiter's volcanic moon Io. The scale of Jupiter's magnetosphere is almost beyond belief. If visible, it would appear larger than the full moon in Earth's night sky, even though the planet itself is hundreds of millions of kilometers away. It is a shield, a trap, and a beacon all at once, shaping the environment far beyond the planet's surface. Studying Jupiter's magnetic field offers insight into the behavior of matter under pressures impossible to reproduce on Earth. It also shows how planets can shape space itself, bending particles and energy on massive scales. Jupiter is more than a giant ball of gas. It is an engine of magnetism, a world whose invisible influence reaches across space. 61, the Big Bang creating time itself. The Big Bang was not simply an explosion in space, but the beginning of space and time together. Before it, there was no where and no when in the sense understood today. The event created not only matter and energy, but also the very fabric of space-time, the stage on which everything else would unfold. To speak of before the Big Bang may not even make sense, because time itself was born in that moment. This idea changes the meaning of beginnings. It is not a question of what filled the void before, but of how the rules of existence themselves emerged. The expansion of the universe was not into empty space, but the stretching of space itself. Every galaxy, every atom, every moment of history was contained in potential within that first burst. The arrow of time began pointing forward in that instant, carrying all events in sequence. The evidence of this origin still surrounds us. The faint glow of the cosmic microwave background is a relic of the first light, stretched across billions of years to reach today. The distribution of galaxies reflects the seeds planted in the earliest instants, ripples in space-time that grew into the structures now seen. Everything from the ticking of clocks to the orbits of planets rests on the foundation of that beginning. To grasp that time itself had a birth is to realize that even the most constant feature of life is not eternal. The past has a horizon beyond which no before exists. The Big Bang is not only the origin of matter, but also the origin of sequence, the moment when change became possible. It is the beginning not just of things, but of beginnings themselves. 62. Every atom in the body forged in stars. The human body, like all matter on Earth, is built from elements that were created in the hearts of stars. Hydrogen and helium formed in the Big Bang, but heavier elements such as carbon, oxygen and iron were fused in stellar cores and scattered by supernovae. Every breath and every heartbeat is made from material that once burned in stars long gone. Life is not separate from the cosmos, but a continuation of its chemistry. The process of stellar nucleosynthesis links biology to astrophysics. Carbon atoms essential for cells, oxygen that fills the lungs, calcium in bones, and iron in blood all originated in stars that lived and died before the sun was born. The solar system formed from the remnants of these explosions, a mixture of gas and dust enriched by countless generations of stars. Each person is, in a literal sense, stardust shaped into living form. This connection is not metaphor but physical fact. The same reactions that light the night sky also supplied the raw material for planets and life. When stars died, they did not simply fade. They gave back their matter, enriching the galaxy, making future worlds possible. Every cell carries a history that stretches back billions of years to the furnaces of stars. To know this is to see life differently. Existence is not isolated on a small planet, but part of a larger cycle, where stars create the elements, galaxies distribute them, and life assembles them into new forms. The body is not only flesh and bone, but a story written by the cosmos itself, a testament that the universe is within as much as it is around. In the quiet rhythm of the cosmos, every discovery becomes a lullaby. Galaxies drift like lanterns on an endless sea. Stars pulse with secret vibrations, and particles whisper through the fabric of space. The universe does not hurry. It moves in cycles and patterns so vast that they stretch beyond memory, reminding that stillness and change coexist. To close the eyes is to join that rhythm, to let thoughts dissolve into the same calm that carries planets in their paths. Tonight, as silence deepens, the sky waits overhead, patient and unbroken, carrying within it stories that will outlast every worry. Sleep comes as naturally as starlight, steady, soft and eternal. If you enjoyed this journey, don't forget to like the video, comment and subscribe to our channel. With your support, we can make this community of science and discovery even bigger. Share your ideas with us, because it's always more exciting to explore the unknown together. As Carl Sagan said, reality may be much stranger than we realize. Science is the most powerful way to understand this strangeness.